Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss about the Eulerian circuit and path, right? So if you are given a graph like this, right? So let's suppose the edges are given, right? Let's suppose a graph is given like this and you have to find the Eulerian path and circuit in this graph. Then Eulerian circuit is Eulerian path is what that if you are able to visit all the edges of this graph exactly once, right, then you can say that Eulerian path is present in that graph, right? For example, starting from a node, if you are able to visit all the edges of this graph exactly once, then you can say that Eulerian path is present in this graph. Now if I start from 0, I am not able to visit all these edges. One edge is left for this graph, right? But Eulerian path is possible for this graph. How? If I start from a node 3, then I can visit all the edges of this graph exactly once, right? So we can say that Eulerian path is possible for this graph, right? Is possible, right? So this is same as the Hamiltonian path, but in Hamiltonian path the condition is for the vertices that if starting from a node you are able to visit all the vertices of this graph exactly once, then Hamiltonian path is present in that graph, right? But in case of Eulerian circuit, if starting from a node you are able to visit all the edges of this graph exactly once, then Eulerian path is possible, is present in this graph, right? And what is now what is Eulerian circuit? That if starting from a node you are able to visit all the edges of the graph and return back to the same node, right, then the Eulerian circuit is present in that graph, right? For example, you are starting from here and you are not coming back to this node again, right? So if starting from a node you are able to visit all the vertices, all the edges of this graph exactly once and come back to the same node, then Eulerian circuit is possible in is present in that graph, right? So this is all about Eulerian path and circuit. Now we can further categorize its study into directed and undirected graph, right? So co-directed and undirected graphs, right? So firstly, let's study about the undirected graph. That how we can detect that whether the Eulerian circuit or Eulerian path is present, possible in that undirected graph or not, right? So in case of undirected graph, if the degree of all the nodes of the graph, degree of all nodes of the graph is even, then Eulerian circuit is present in that graph. Then Eulerian circuit is present, right? So now degree is what? Degree of a node is the number of edges connected to the node, right? For example, degree of this three is what? 1, 2, 3. Why? Because three edges are connected to this node. Degree of this node is 2. Why? Because two edges are connected to this node. Degree of this node is also 2. Why? Because two edges are connected to this node. So if in an undirected graph, degree of all the nodes is even, then Eulerian circuit is present in that graph. Now why? Because when degree of all the nodes is even, this means that at least one incoming and one outgoing edge is there like this. So there is a node like this. Now this node must be connected to all the edges, right, like this. Hmm. like this, right? So this condition is always true, that if the degree of all the nodes of a graph is even, then the Eulerian circuit is possible in that graph. That is, we can visit all the edges of this graph and return back to the same edge from where we started, right? So the Eulerian circuit is possible, is present in this undirected graph. So what is the condition? The condition is that the degree of all, that is the number of edges connected to all the nodes of the graph, must be even, right? Now this is the condition for Eulerian circuit. Now what is the condition for Eulerian path? So for an undirected graph, if degree of exactly n minus 2 edges, n minus 2 nodes, degree of n minus 2 nodes of the graph, if must be even. So if this condition is true, then Eulerian path is possible. There, that is, Eulerian path must be present in that graph. Now how? Right, Eulerian path. Now the condition is that the degree, that is the number of edges connected to all the nodes, to n minus 2 nodes of the graph, must be even. Now this means that the two nodes must have odd degree, that is something like this. All other nodes have even degree, but two nodes have odd degree. Now these two nodes must be the starting and the ending node, right? So all other nodes, by using all other nodes, we can visit all the edges of the graph exactly once, and these two nodes with odd degree must be the source and the destination nodes, right? So this is something like this. So all these nodes are connected with each other. These are the starting and the ending node. This will be the starting node, this will be, or this will be the starting, or this will be the ending node. So it is possible to visit all the edges of the graph exactly once, starting from a node, right? So Eulerian path is possible, is present in this graph, in this undirected graph. So what is the condition? The condition that is that the degree of n minus 2 edges must be even. So the degree of 2 edges must be odd, right? So if Eulerian circuit is present in a graph, then Eulerian path should be present, must be present in that graph, right? So but there is a special condition, that if n minus 2 nodes of the graph have even degree and two nodes have odd degree, then Eulerian path is present. But it is possible that Eulerian path is present in some graph, but Eulerian circuit is not present, right? So this condition is always true, that if Eulerian circuit is present, if Eulerian circuit is present, then Eulerian path must be present. Eulerian path is also present, also there. But vice versa is not true, right? But vice versa is not true, which means that it is not always true that if Eulerian path is present in a graph, then Eulerian circuit is also present, right? It is possible that, for example, in this graph, Eulerian path is present. How? That starting from a node, we can visit all the edges of the graph exactly once. But this is not, but Eulerian circuit is not present here. How? Because when we are starting from any node, we can't come back to the same node after visiting all the edges of the graph, right? So if I start from this, right, so this is not even Eulerian path. If I start from this, right, so no Eulerian circuit is present in this graph, but Eulerian path is present. So this condition is that if Eulerian circuit is present in a graph, then Eulerian path must be present. It is obvious now, if Eulerian circuit is there, that is, we can visit all the edges and come back to the same edge again. So this is also the Eulerian path also, right? So these are the two conditions, that if the degree of if an undirected graph is given to you, then if the degree of all the edges, all the nodes of the graph, that is the number of edges connected to a node, the degree of all the nodes of the graph is even, then Eulerian circuit is present in the graph. And if degree of n minus 2 nodes of a graph is even, that is the two nodes contain the odd degree, then Eulerian path is present in that graph, right? Also, this is the condition that if Eulerian circuit is present, then Eulerian path must be present. But the vice versa is not true. That is, it may be possible that Eulerian path is present, but Eulerian circuit is not there, right? So now let's discuss for the directed graphs. Directed graphs. Now for directed graphs, the condition is that if the in degree is equal to the out degree, for all the nodes of the graph, then Eulerian circuit is present, right? Eulerian circuit is present. Now this condition is that now in case of undirected graph, the degree can be in degree or out degree. Now in degree is that if an edge is coming towards a node, right? Out degree is that if an edge is going towards from the node, right? So the in degree of this node is 1, the out degree of this node is 1, right? In degree is also 1, out degree is also 1, right? The in degree of this node is 1, the out degree is 0, because no node is coming out of this, no edge is coming out from this node, right? So for example, if a graph is given to you like this, right? Now the in degree of this node is 0. Why? Because no edge is coming towards this node, right? The out degree of this node is 2, because two edges are going from this node, right? Similarly, the in degree of this is 1, because one edge is coming towards this node. The out degree of this is also 1, because one edge is going from this node, right? So this is about the in degree and out degree of a node in case of the directed graphs, right? Now if the in degree of all the nodes of the graph is equal to the out degree, right, then the Eulerian circuit is present in that graph. Now how? Now if let's these are the nodes, right? In degree is, out degree is also 2, in degree out degree is 2, in degree is also 2, right? Out degree is 1, in degree is also 1. Then Eulerian part must be present. How? Now this node must be connected to this is must be connected to this must be connected to something. Out degree is 1, so in degree must also. Now this should also be connected with something, right? Now in degree of this is 1, out degree should also be 1, right? So you can see that Eulerian circuit is present in these type of graph, right? So you can visit all the edges and return back to the same node. So Eulerian circuit is present. So if in degree of all the edges is equal to the out degree, then the Eulerian circuit is present in an undirected graph, right? So now it is obvious that if Eulerian circuit is present, then Eulerian path is also present. But there is a special condition for Eulerian path also, that if the in degree is equal to the out degree for n minus 2 edges, n minus 2 nodes, then Eulerian path is present. Now here all the nodes should have the same in degree and out degree, but in case of Eulerian path, n minus 2 nodes must have the same in degree and out degree, and two nodes can have. Now the two nodes are, the first node should be, for first node the in degree can be more, right? So in degree can be more, that is in degree can be out degree plus 1. For second node the out degree can be more, that is out degree is in degree plus 1. Now what is this case? This is that now for all the nodes the in degree and out degree is exactly same, right? In degree, out degree, in degree, out degree, in degree, out degree, right? But for two nodes the in degree is more, right? So in degree is 2, out degree is 1. In for second node the out degree is more, out degree is 2, in degree is 1. Now how this is possible? This is like, this must be connected to 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 this. Now this is possible that, let's suppose, so this is the Eulerian path is possible that we can start from a node and we can visit all the edges of this graph exactly once. Now two nodes, these two nodes must be the starting and the ending node, right? So this can be the source and this can be the destination. Clearly in case of source the in degree is always lesser, right? Why? Because source is the starting point. Now for destination always the out degree is lesser. Why? Because destination is the ending point, no out degree is possible here, right? So this is the case for Eulerian path, that is if for n minus 2 nodes the in degree and out degree must be same, but for two nodes the in degree for first of the node, for one of the node the in degree is greater, for second node the out degree is greater, that nodes must be the source and the destination, right? So for directed graphs, if the in degree and out degree of all the nodes are same, then Eulerian circuit is possible. If the in degree and out degree of n minus 2 nodes are same, but for two nodes the in degree of either the in degree or the out degree is greater, then Eulerian path is possible. Similarly, for the undirected graphs, if degree of all the nodes is even, then Eulerian circuit is possible. But if the degree of n minus 2 nodes is even and the degree of 2 left nodes is odd, then Eulerian path is possible, right? So I hope you understand that Eulerian path is what? That if you start from a point and you can visit all the edges of this graph exactly once, then Eulerian path is present in that graph. But if you start from a node and after visiting all the edges of the graph exactly once and you return back to the same node, then the Eulerian circuit is present in that graph. So these are the two methods that how you can check that if Eulerian circuit or paths are present in an undirected or any directed graphs or not, right? So this video is about to how you can check that if the Eulerian circuit is present or not in any undirected or directed graphs, right? So I hope you understand that how to find whether the Eulerian circuit is present in any graph or not, and what are the Eulerian path and Eulerian circuit, right? So we'll meet in the next video. Till then, take care. Bye bye. Thank you for watching.